As promised, Mr. Field is represented by Bat Heart today, and Mr. Guessford is King Thyroid. Now, I don't have a shelf as I had planned, so they're going to go sit over here. If you don't know what either of those organs are, feel free to go look them up. Although if you don't know what a heart is, I'll be very disappointed in you. Exponents is the theme of today's conversation. In fact, it'll be the theme of this entire week's conversation. Really, we're going to spend this week refreshing what you learned in 7th grade. It's been a while, so I highly suggest you do all of the lessons. But again, I'm only requiring 3 from you. Exponents, if you don't remember, exponents come in 2 pieces. First, you have what we call a base. Let's make that base 2. Now, the base is the number that we're going to represent multiple times. The second part is an exponent, or what we like to call a power. Let's say we're going to raise this to the power of 3. This is a power. So this is 2 raised to the power of 3. Now, a very common misconception for this is that 2 times 3 is 6, which is true, but it's not how this one works. This is the case where this never gets multiplied by 2. Never. This is simply telling me how many times I have 2. So in this case, I have 2 3 times. So I'd write that out as 2 times 2 times 2. Okay? Again, 2 is not multiplied by 3. This does not equal 6. This equals 8. 3 is just telling me how many times 2 occurs. Now, I like to think of this like 2 is an app, and 3 is the notification bubble, telling me how many notifications I have. So if you take a look at your phone right now, I guarantee you have notifications. Maybe it's just emails. For instance, I have 14 apps that need to be updated in the App Store. That's a notification bubble. That's telling me that there are 14 somethings I need to do. And it collects them all into that notification bubble, which is what this is doing. Somewhere along the line, someone decided writing out 2 times 2 times 2 was too annoying. And so they came up with exponents that basically condenses it and makes it easier to look at. So, we're going to go over this one more time. 2 is the base. You do not multiply anything by the base, except for the number it's actually multiplied by, which is itself. Exponents are always itself. This is what I like to call repeated multiplication. Now, if you were all there, I would say, what is multiplication? And you should all reply, it's repeated addition, Miss Knock. It's the same idea. Exponents is just repeated multiplication. Literally, I'm going to repeat it over and over and over and over again. And unlike multiplication, where we've learned a whole bunch of tricks to get around having to add, this is basically what you're going to do, unless you have a calculator handy, which is a good idea. Now, before I let you go on to the rest of the lesson, I wanted to point something out to you. Last week, we worked with interest. You guys should have seen both simple and compound interest. Simple interest has a linear pattern. It goes up by the same amount every time. If you start with adding $10, you will add $10 until the end of time, whenever you take your money out of the bank account. Compound interest, I never gave you a formula for, because the formula involves exponents, and you don't quite know those yet, or know how to work with them in context of compound. If this, I should not have erased that, is simple interest's graph, this, hopefully you graphed compound interest, you should have gotten something like that. That is what we call an exponential function. It comes exactly from exponents. Let's say I'm going to have an exponential function of 2. So x raised to the 2nd power. We would start out by adding 2. Nice and low. Okay. And then we would add 4. Remember, we're multiplying by 2 every time because that's how something raised to the 2nd power works. Or, sorry, this would be 2 raised to the x power. I apologize. We're multiplied by 2 again, so now we add by 8, and now we're adding by 16, and now it's 64. And if we kept going up, it would now be 256, and so on and so on and so on. An exponential curve makes this curve because I'm adding differently all along the way. That's the 6, by the way. I'm not adding consistently, which is what makes linear. If you recall, the main definition of proportional is that it is consistent growth, which is the same with anything that's linear. You add the exact same thing every time. That's how we generalize slope. This doesn't have a slope because the number changes every time. It would have a formula looking something like that, though. This is really important that you guys learn to read this, because if you go just look up any data on the coronavirus right now, it's going to come in exponential curves, because one person, according to the CDC, can infect up to 2 people. It's like 2.8, but for the purposes, we'll say 2 people. If one person infects 2 people, that's a +2 growth, right? But now you have 2 more people that are infected. They're going to infect 2 more people. That's a +4 growth. They're going to infect 2 more people. That's a +8 growth. And it's going to keep going like this. That's, should say +8. This is a +16 growth, and then it's +64, then +256, and this can happen all in one day. We're not counting that this original person, if they're still let loose on society, can infect another 2 people the next day, and that each of these people who's been infected can then go infect another 2 people the next day. This is why this is dangerous. This is why you guys are inside right now. This is why we are not at school. Because that gets huge really fast. If you can infect 2 people a day and you're not social distancing, you're not quarantining, you're going to infect a whole bunch of people. And somewhere along the lines, we're going to have an old person, an immune-compromised person, a cancer patient. They die. So think about that before you want to go outside and play with playground equipment. Because you might infect a kid who takes it home to their grandparents. And this is not okay, guys. Now, what I do want to show you, which is really cool, let's say person 1 is going to infect 2 people. This person decides they are not going to go outside. They're in quarantining. I've just taken down half that. Let's say this person decides to social distance wearing a mask and gloves. They're not infecting anyone. And then this person decides not to do anything. And it just decreases the infection rates, which is why you guys are not outside right now. That's why you're not at school surrounded by your peers that you could infect, and they could take it home to people who could actually get hurt by this. With that depressing news, you guys can move on to the next slide. If you need any of this down in writing, the next slide has the notification bubble explanation. And then 2 more slides after that, you have explanations on how to evaluate and expand, and I'll get back to you on how to expand multiple exponents at one time.